Welcome to the second session of training for hazards associated with handling of chemical and petroleum products. Today's topic will be HazChem and NFPA or fire diamond. The contents of today's discussion will be 1. What is HazChem? 2. What is Emergency Action Code? 3. Decoding the Emergency Action Code for the method of suppression of fire and the HazChem safety parameters. Then we will look for some examples and calculations for multi-load vehicles. After HazChem we will move to NFPA diamond. We will discuss various color codes and what they mean. Also we will discuss the nomenclature and
What is HazChem, and what information is given in HazChem plate? HazChem is a warning plate system used for vehicles transporting hazardous substances and on storage facilities. A sample HazChem plate, as you can see on the screen, contains the following details. The top left section of the plate gives the Emergency Action Code or EAC, telling the emergency services like the fire brigade about what actions they have to take if there's an accident. The middle left section gives the UN substance identification number describing the chemical. The lower left section gives the telephone number that should be called if any specialist advice is needed. The warning symbol at top right indicates what danger the chemical presents. The bottom right of the plate may or may not carry a company logo. There is also a standard null HazChem plate to indicate the transport of non-hazardous substances. The null plate does not include an EAC or substance identification number. What is Emergency Action Code? The Emergency Action Code or EAC is a 3-character code, which is displayed on all dangerous goods classed carriers and provides a quick assessment to first responders and emergency responders, like the firefighters and police, about what actions they should take if the carrier carrying such goods gets involved in an incident, such as traffic collision. EACs are characterized by a single number ranging from 1 to 4, and either 1 or 2 letters which completely depend on the hazard. Dangerous Goods Emergency Action Code list is reviewed in every 2 years. It is an essential compliance document for all emergency services, the local government, and for those who may control the planning and prevention of emergencies involving dangerous goods. Let's see what does the characters in the Emergency Action Code show. First character in the code is always a number ranging from 1 to 4. This number is indicative of what type of fire suppressant should be used to suppress a fire from igniting or extinguish a fire caused by the chemical. Wherever number 1 is given, it shows that the chemical needs water jets as fire extinguishing medium. Number 2 similarly means fog as extinguishing medium. However, in the absence of fog equipment, a fine spray may be used. The number 3, which we generally see everywhere around us, holds use of foam as extinguishing medium. Number 4 means chemical requires dry agent like carbon dioxide or halon substitutes. The system is designed to rank fire suppression methods in order of usability. For example, a chemical marked with the number 2 or fog can be suppressed with methods 3, foam, or 4, dry agent, but not with 1, that is water jets. The dry agent method must be used for chemicals that have an undesirable reaction with water and must not be allowed to come in contact with water. Therefore 4 is the highest ranking suppression method. Because all the other methods use water, water must not be allowed to come into contact with the substance at risk. Each EAC contains at least 1 letter, which determines which category the chemical falls under, and which also highlights the violence of the chemical, that is, likelihood to spontaneously combust, explode, what personal protective equipment to use while working around the chemical, and what action to take when disposing of the chemical. Each category is assigned a letter to determine what actions are required when handling, containing, and disposing of the chemical in question. There are 8 major categories which are commonly denoted by a black letter on a white background. 4 subcategories exist which specifically deal with what type of personal protective equipment responders must wear when handling the emergency, denoted by a white letter on a black background. In Australia, with the update of the Australian Dangerous Goods Code Volume 7 in 2010, the white letter on a black background has been removed, making BA as a requirement at all large incidents regardless of whether the substance is involved in a fire or not. If a category is classed as violent, it is denoted by letter V. This means that the chemical can be violently or explosively reactive, either with the atmosphere or water, or both, which could be marked by dangerous when wet symbol. Protection is divided up into 3 categories of personal protective equipment: full breathing apparatus and breathing apparatus for fire only.
Full denotes that full personal protective equipment provisions must be used around and in contact with the chemical, which will usually include a portable breathing apparatus and watertight and chemical-proof suit. BA, acronym for breathing apparatus, specifies that a portable breathing apparatus must be used at all times in and around the chemical, and BA for fire only specifies that a breathing apparatus is not necessary for short exposure periods to the chemical but is required if the chemical is on a light. BA for fire only is denoted within the Emergency Action Code as a white letter on a black background, while a black letter on a white background denotes breathing apparatus at all times. When changing the background color is not possible, such as with handwriting, the use of brackets means the same as a black background. 3. YE, when written with Y in brackets means the same as a white letter on a black background. Substance control specifies what to do with the chemical in the event of a spill, either dilute or contain. Dilute means that the chemical may be washed down the drain with large quantities of water. Contain requires that the spillage must not come in contact with drains or water courses. In the event of a chemical incident, the Emergency Action Code may specify that an evacuation may be necessary as the chemical poses a public hazard which may extend beyond the immediate vicinity. If evacuation is not possible, advice to stay indoors and secure all points of ventilation may be necessary. This condition is denoted by an E at the end of any Emergency Action Code. It is an optional letter, depending on the nature of the chemical. Let's try to understand by examples. For EAC3, YE, looking at the table, we deduce that we have to use foam or dry agent. Substance reacts violently or is explosive. BA use is essential for Y without black background, evacuate vicinity and contain spill. Again for 3Y, E, containing Y with black background, we need to use foam or dry agent. Substance reacts violently or is explosive, use BA if fire present, evacuate vicinity, and contain spill. For code 2R, we deduce use of fog, foam or dry agent, the substance is not violent, useful PPE, and dilute spill. Now let's see. For X, it says, use dry agent only. The substance is not violent, full PPE are essential, and contain the spill. Can you now deduce code 1S? E. Will it say use jets, fog, foam or dry agent? Breathing apparatus is required for fire only, evacuation is also needed and dilute the runaway chemical. Let's see calculation of HazChem action code for multi-loads or sites with multiple HazChem codes. Example. There are 3 substances to be carried as a multi-load, having emergency action codes of 3Y, 2S and 4WE. The first character of the EAC for each of the 3 substances is 3, 2 and 4. The highest number must be taken as the first character of the code for the multi-load and therefore the first character will be 4. The second character for the EAC for each of the 3 substances is Y, S and W. Let's see the characters in the table. Substance control has top character as a most severe case of impact. It means in dilution type chemicals P will have more hazard than R, S, and T, also R will be more dangerous than S or T, so the protection method also reduces as we move from P to T. Unlike dilution type chemicals W will have more hazard than X, Y or Z. Same as the protection method reduces in dilution group, same will be followed here, also we can say P and W hold same level of hazard, the only difference will be that W cannot be washed away while P can be. Same is with R and X, S and Y and T and Z, all these need same protection level as it is evident in the table. So when we have to compare S and Y we will prefer Y as it needs to be contained though it has same hazard as S and needs same protection standards, but when we have to choose between R and Y, we will have to choose R because it needs better protection level. Applying these principles we will choose Y from the given 2 that is 3Y and 2S. This resultant character, Y, is then taken and co-paired with W which is the most hazardous material and needs full body protection. So our third character will be W. The third substance has E as a third character and therefore the multi-load must also have an E. The resultant HazChem code for the 3 substances carried as a multi-load will therefore be 4WE.
What is the NFPA diamond?
NFPA 704, Standard System for the Identification of the Hazards of Materials for Emergency Response, is a standard maintained by the National Fire Protection Association. It was first adopted as a guide in 1960 and revised several times since then. It defines fire diamond used by emergency personnel to quickly and easily identify the risks posed by hazardous materials. This helps to determine what special equipment should be used, what procedures have to be followed, or precautions to be taken during the initial stages of an emergency response. What are the color codes saying in NFPA diamond? The 4 divisions are typically color-coded with red indicating flammability, blue indicating level of health hazard, yellow for chemical reactivity, and white containing codes for special hazards. Each of health, flammability and reactivity is rated on a scale from 0, no hazard, to 4, severe risk. The numeric values in the first column are designated in the standard by degree of hazard, using Arabic numerals 0, 1, 2, 3, and 4. Let's see the first square of the NFPA diamond. It shows flammability and is indicated by red. Number 0 on red square means materials that will not burn under typical fire conditions, including intrinsically non-combustible materials such as concrete, stone and sand. These materials will not burn in air when exposed to a temperature of 820 degrees centigrade for a period of 5 minutes. The number 1 means materials will require considerable preheating under all ambient temperature conditions before ignition or combustion can occur. It includes some finely divided suspended solids that do not require heating before ignition. These have flash point above 93 degrees centigrade like mineral oil and ammonia. The number 2 means chemical must be moderately heated or exposed to relatively high ambient temperature before ignition can occur, like diesel fuel, paper, and sulfur. Also, multiple finely divided suspended solids that do not require heating before ignition can occur. These have flash point between 37 and 93 degrees centigrade. Number 3 means liquids and solids, including finely divided suspended solids, can be ignited under almost all ambient temperature conditions, such as gasoline and acetone. These are liquids having a flash point below 23 degrees centigrade and having a boiling point at or above 37 degrees centigrade, or having a flash point between 23 and 38 degrees centigrade. Number 4 means substance or chemical will rapidly or completely vaporize at normal atmospheric pressure and temperature, or is readily dispersed in air and will burn readily, such as acetylene, propane, hydrogen gas. Includes pyrophoric substances. Flash point of these are below room temperature or 20. Now let's see the blue diamond, which indicates level of health hazards. A chemical having 0 in blue diamond poses no health hazard, no precautions are necessary and would offer no hazard above and beyond that of ordinary combustible materials, like wood and paper. The chemicals with number 1 means exposure to these chemicals would cause irritation with only minor residual injury, like acetone, sodium bromate, and potassium chloride. Chemicals with number 2 on intense or continued but not chronic exposure could cause temporary incapacitation or possible residual injury. Some examples of these are diethyl ether, ammonium phosphate, and iodine. Chemicals with number 3, short exposure to these could cause serious temporary or moderate residual injury, like liquid hydrogen, carbon monoxide, calcium hypochlorite, and hexafluorosilicic acid. The deadly 4 means very short exposure to these chemicals could cause death or major residual injury, like hydrogen cyanide, phosgene, methyl isocyanate, and hydrofluoric acid. I hope you can identify poisonous chemicals having 4 in blue diamond on their label next time. Moving to next cube, the instability or reactivity indicator shown by yellow color code. 0 rating means these are normally stable even under fire exposure conditions and are not reactive with water, like helium and nitrogen. Rating 1 is given to those chemicals which are normally stable, but can become unstable at elevated temperatures and pressures, such as propene. Rating 2 means chemical undergoes violent chemical change at elevated temperatures and pressures, and reacts violently with water, or it may form explosive mixtures with water, such as white phosphorus, potassium, and sodium. 3 rating is given to substances which are capable of detonation or explosive decomposition but requires a strong initiating source. They must be heated under confinement before initiation. They react explosively with water, or will detonate if severely shocked. Examples of these are ammonium nitrate, cesium, and hydrogen peroxide. The unstoppable 4 means the marked substance or chemical is readily capable of detonation or explosive decomposition at normal temperatures and pressures. Examples of these capable bombs are nitroglycerin, chlorine dioxide, nitrogen triiodide, and chlorine trifluoride. Special notice is given in fourth section or cube shown by white color. The white, special notice, area can contain several symbols. The following symbols are defined by the NFPA 704 standard. OX means oxidizer. It allows chemicals to burn without an air supply, such as potassium perchlorate, ammonium nitrate, and hydrogen peroxide. Cross W means it reacts with water in an unusual or dangerous manner, like cesium, sodium, and sulfuric acid. SA means simple asphyxiant gas, like hydrogen, nitrogen, helium, neon, argon, krypton, and xenon. Non-standard symbols are also used in white cube. These hazard codes are not part of the NFPA 704 standard but are occasionally used in an unofficial manner. The use of non-standard codes may be permitted, required, or disallowed by the authority having jurisdiction like fire department. COR means corrosive or strong acid or base, such as sulfuric acid and potassium hydroxide. Acid or ALK means acid or alkaline, to be more specific. BIO or shown symbol means biological hazard, such as flu virus or rabies virus. POI means poisonous, like strychnine or alpha-amanitin. RA or RAD means radioactive, such as plutonium and cobalt-60. CRY and CRYO means cryogenic, such as liquid nitrogen. Let's see some examples of NFPA diamond. They can be found on any material safety datasheet, or on the bottling or packing labels of chemicals, or on user guides, etc. It can be shown as a diamond, or the degree of hazard can be written in tabular form as shown. This is a view of material safety datasheet of superior kerosene oil or SKO. MSDS for anthraquinone is also shown here. Can you decide which of the two will be more flammable? Shown here is MSDS for diesel fuel. The table shown on right side is known as HMIS or Hazardous Materials Identification System code, and it is completely different from NFPA diamond. Though it may look similar, HMIS is not used as widely as NFPA system. Now this is the NFPA diamond from the gasoline or petrol's MSDS. That's all for today. Thank you.